Welcome back to the Tech Stack Learning Channel, your go-to hub for deconstructing the modern AI development stack. We bridge the gap between basic concepts and production-grade implementation that in the world of LLMs and RAG systems. Size matters, specifically, the size of your data. Large documents can't just be poured into a model, they need to be strategically broken down. Today, we are performing a deep dive into LangChain Text Splitters. Text splitters are the unsung heroes of retrieval accuracy. If your chunks are too large, they won't fit within context limits. If they are too small, you lose the semantic meaning. In the next few minutes, we will master the art of chunking, from the industry-standard recursive character splitter to specialized strategies for Markdown, JSON, and code. Before we get started, if you haven't subscribed to my channel, please subscribe.
All right, if you're building anything with LLMs, you have definitely hit that frustrating wall where you try to feed a giant document into your RAG system and it just fails. Well, today we are doing a deep dive into the one tool that is absolutely essential to solving this, LangChain Text Splitters. So let's just start with the most basic question, right? Why can't we just give the entire PDF or the whole book to the LLM and call it a day? Well, the answer gets right to the heart of how these models work and one of their biggest limitations. And this is where text splitters come into the picture. They're these super clever tools with two critical jobs. Job number one, chop up those big documents into pieces that can actually fit inside the LLM's context window. And job number two, which is just as important, is to make those pieces really focused and meaningful so you get way better results from your RAG system. Okay, but how do you split a document without, turning it into a complete mess? It all boils down to two fundamental ideas, chunking and something called overlap. Let's start with what can go wrong. Imagine you just blindly split your text every 1,000 characters. You could easily chop a super important sentence right in half. The first chunk ends, the next one begins, and that crucial connection, that context between them, it's just gone. Poof. And this is why chunk overlap is your absolute best friend. The idea is simple but powerful. You make the beginning of each new chunk repeat the last few sentences of the chunk before it. This creates what's called a semantic bridge. It's like giving the model a little running start into the next piece of text, making sure nothing important gets lost in the gap. Okay, so now that we've got the core idea down, let's meet the star of the show. Seriously, this is the tool you're going to use probably 90% of the time. It's the Recursive Character Text Splitter. And look, there's a really good reason why LangChain makes this the default. It's not just another option, it's the Swiss Army knife of text splitting. It's your all-purpose go-to solution. So what's its secret sauce? Well, it's pretty brilliant. It has a priority list of how to split things. First, it tries to split by paragraphs, those double new lines. If the chunks are still too big, it falls back to splitting by sentences, then by words, and only as a last resort does it split by individual characters. It's this hierarchy that makes it so good at keeping the meaning together. So the bottom line is this. It just automatically adapts to whatever text you throw at it, doing its absolute best to preserve the original structure. For most things you're going to do, this is the perfect place to start. But not everything is a plain text file, right? What happens when you're dealing with something more specific, like code or a Markdown file? Well, for that, LangChain basically opens up an entire toolkit of specialized splitters. First up, let's talk about precision. For those times when close enough just isn't good enough, you need the token text splitter. And why does this matter so much? Here's the key thing to remember. LLMs don't think in characters, they think in tokens. A single word, like running, could be one token, but a more complex word could be 2 or 3. So when you're in a production system, trying to manage costs and context limits perfectly, splitting by the actual token count is the only way to be truly precise. Okay, next tool. If you're working with structured documents, think about your project's README file or any online documentation. You're probably dealing with Markdown, and for that, there's the Markdown Text Splitter. What's so cool about this one is that it doesn't just guess where to make the cuts. It actually uses the structure you already created, your headings and subheadings, to create the chunks. It's so much smarter. There's even an advanced version that automatically adds the heading as metadata to each chunk, which, let me tell you, can be a game changer for getting accurate answers. All right, let's talk about a big one for a lot of you watching. Code. You can't just throw a Python script into a regular splitter and hope for the best. You need a splitter that actually speaks the language. And that's exactly what these do. I mean, can you imagine anything worse than splitting a function definition right down the middle? It would be useless. These language-aware splitters for Python, JavaScript, and a bunch of others, they understand the syntax. They see your classes and functions and keep them together, which is absolutely essential if you're building any kind of code Q&A bot.
And of course, in the world of APIs and configs, we can't forget about JSON. For that, you've got the recursive JSON splitter.
You know how JSON is all about that nested structure of keys and values? Well, this splitter's entire purpose is to understand and preserve that hierarchy. So instead of flattening your data into a messy string, it intelligently breaks up huge JSON files while keeping that all-important structure totally intact.
Whew, okay, that was a whole lot of tools we just unpacked. So the big question is, how in the world do you choose the right one? Don't worry, I've got a super simple playbook right here to make it easy.
Seriously, you might want to screenshot this. This is your cheat sheet. For general text in RAG, recursive character. If you need absolute precision on token counts for production system, token text splitter. Working with documentation, Markdown header. Code, a language splitter. JSON, well, recursive JSON. It really is a pretty straightforward decision tree.
Look, if you walk away with just one thing from all this, let it be these 3 golden rules. Rule number 1, always start with recursive character text splitter. Rule 2, a great starting point for tuning is a chunk size around 1,000 and an overlap around 200. Play with those numbers based on your results. And rule 3, only grab one of those specialized splitters when you're dealing with a specific data type, like code or Markdown, that really needs it. So there you have it. You're now totally equipped to take basically any document and chunk it up perfectly for your LLM. But, and this is a big but, getting the chunks right is really only half the battle in a great RAG pipeline, which leads to the next big question.
We have covered a lot today. From understanding how text splitters improve retrieval accuracy and semantic coherence, to exploring the full range of LangChain strategies, including character, token, and structure-aware splitters for JSON, HTML, and code. If this deep dive helped you master your tech stack today, please hit the subscribe button and join our community. Thank you so much for watching. I'm looking forward to seeing what you build. I'll see you in the next one.